ISBM, your first step towards right career.
Good morning, friends. Let's start with another chapter of the same quantitative techniques. It's a queuing and simulation. What exactly the queuing and simulation we will learn in this chapter? Queuing is nothing but just like what we have seen in normal days life. Just like if you want to go for ticketing to get a ticket for train or for bus for anything, so we are in queue to get that ticket. Either you are going for a ticket for movies or anywhere. So we are in a queue. First come is first out. This is the process in the queuing. My mentor say which come first, they will take ticket first and they will go out like that. So this is the process of queuing, and we will learn queuing little bit detail, what is the process for queuing and how will working on the queuing we'll see over here. Let's start. See, this is the queuing, like queue. What I have asked you about. What is the queuing theory? Why it is an important tool. Example of different queuing system we will learn, and components of a queuing system. The exponential distribution in queuing, stochastic process, some definitions, the Poisson process, terminology, what terminology we will use for the queuing and their notation, then little formula, what exactly the formula through which we will get the queuing answer, then birth and death process, what exactly the birth and death process in the queuing we will learn over here. So this is the overview, entire overview, how we will go for to learn the queuing. We will start with some theoretical part, then we will go for some formula, mathematical side in which we will learn the formula. We will go ahead like that. So start with the overview. Important queuing models with FIFO discipline. FIFO, what I have asked you about. First, FIFO, F-I-F-O. FIFO is stand for first in, first out. F first in, I for in, F for again first out. First in, first out. Which in the queue, who will come first will take the ticket and go out. Like that. First come, first out. There is some discipline for FIFO, MIM model, MMC model, MMC K model, and MMC sigma N model, which is last two models, which is asked about limited queuing capacity and limited calling population. Priority discipline queuing models, application of queuing theory to system design and decision. What exactly the application of the queuing theory in our system designing and decision, how to making the decision? We will see these things in the queuing model also. Then third, we'll overview about the simulation. What exactly the simulation, why it is important tool, building a simulation model, discrete event simulation, structure of BPD simulation project, model verification and validation, example of simulation in a queuing model, MMI1 queuing model. These things we will see. So what initially we have seen an overview first. What is the queuing and queuing theory? So we will start with the queuing theory. What exactly the queuing theory? So it is a mathematical analysis of a queue and waiting times in stochastic system. See, we are doing in a queue, basically we wait for something. We wait just like in a simple example, in a queue for a railway line, in a railway line, in a queue we will wait for tickets. So when we will get tickets, then it's I can say our target is completed. We're standing on the queue. So it is kind of analysis. We will do mathematical analysis for queue and waiting times. How much time we have to wait? Just like if you are not in first, then if you have if you are 9th or 10th or some other position in the queue. So what exactly the waiting time? So we will learn the waiting time also with the help of stochastic system. In a stochastic system, use extensively to